Okay, let's look at this question from the Mind Action series, exercise 14, mixed examples, and it's question number 4. So it says, ammonium nitrate is a good fertilizer because it's very soluble and provides a large amount of nitrogen to plants. It can be made from ammonia and nitric acid as follows. Now you need to pay attention to this equation because it will be in grade 12. This is produced by the Haber process and then the Ostwald process, so this is a good reaction to know. So here goes ammonia plus nitric acid gives you ammonium nitrate. It says to you if 1161 grams of ammonium nitrate were obtained when 340,6 grams of ammonia were reacted, calculate the percentage yield. So now if you look in this question here, we've got two knowns. Remember, we always have to turn the known things into moles. What are you given? And we're given ammonium nitrate and we're given ammonia. Okay, so now ammonium nitrate is a product, and if we're calculating percentage yield, we know that this amount of ammonium nitrate is never ever actually going to be the maximum amount of ammonium nitrate, because percentage yield is less than 100%. So if this ammonia reacted completely, that would give us 100% yield, but it's obviously not, and so that's why we've got a percentage yield. So at this moment, ammonia is controlling this reaction. If we know how many moles of ammonia we've got, we can get the theoretical yield. So our first thing to do is to have a look. What is the relative molecular mass of ammonia? And that will be 14 plus 3 hydrogens, which is going to give you 17. Okay, so if we look at 4.1, we want to calculate the number of moles of ammonia that we have. Okay, so we're going to use M over big M, and we've got here, what have we got, 340.6, and it is divided by 17. So if we plug this in our calculator, we get something like 20 moles, 20,035 moles of ammonia. So now, according to this reaction, if we look at the mole ratio, okay, 1 mole of ammonia reacts to produce 1 mole of ammonium nitrate. So now, I don't know if you remember, but ammonium nitrate is a good fertilizer, but it's also the explosive used in quarries. So it's quite a common explosive. So with the ratio 1:1, we would produce 20,035 moles of ammonium nitrate if we assumed 100% yield. So this number of moles of ammonium nitrate is our theoretical yield. But now if we want to calculate the maximum theoretical yield, we are going to need again the relative molecular mass of ammonium nitrate. So we've got 2 nitrogens in there, which is going to be 28, plus the 4 hydrogens, plus, 48 for the oxygen, because it's 16 times 3. So you should end up with something like 80 grams per mole. Okay, so now our maximum theoretical yield, so theoretical yield is going to be, so we say M equals NM, which is going to be 20,035 multiplied by 80, which should give us, what is this going to give us? 1,602 grams, 82. Okay, you'll see that your answers are slightly different to the answers in the textbook, because the textbook used a different periodic table. Okay, so now if we want to calculate the percentage yield, my handwriting, the percentage yield is the actual yield over the theoretical, okay, times 100. So the actual yield is, what is it in the question here? 1161. So it's 1161 over 1602,82 times 100. to get a percentage, so this is going to be 72.43%. Okay, so that's my theoretical yield. So that's fine. Then it says to you, ammonium nitrate is also used as an explosive because it decomposes on heating according to this equation. Let's see if we can do this in a different color pen to distinguish it. Okay, ammonium nitrate is also used as an explosive because it decomposes on heating according to this equation. 2 ammonium nitrate gives you 2 moles of nitrogen, 4 moles of water. And can you see they're coming out as a gas? Obviously because this reaction is strongly exothermic and produces a lot of heat, and some oxygen gas. So it says to you, if the ammonium nitrate prepared as above was heated, what total volume of gas would be produced at STP? So fairly obviously, if they want the volume of gas at STP, we're going to use N equals V over Vm, where Vm from the data sheet is going to be 22.4 cubic decimeters per mole. So if we have a look here, 2 moles of ammonia are going to produce how many moles of gas? 2 and 4 and 1. That is 7 moles of gas total on the right hand side. So you can use the mole ratio because it says what volume of gas. So this has got a gas, this has got a gas, this has got a gas. You add them all together. So if you have a look here now, the mole ratio now, okay, is 2 ammonium nitrates to 7 gas. So if you want to, you can use the mole ratio to work out how many this is, how many this is, and how many that is. But I'm like, okay, let's add them all up. We've got 7 moles of gas altogether. But we need to know, in actual fact, we only produced this many grams of ammonium nitrate in the beginning. So we need to find out how many moles of ammonium nitrate we had. So the number of moles of ammonium nitrate produced in part 1 of the equation, it's going to be M over M. So what was this? 1161. And we worked out the relative molecular mass here was 80. So the number of moles of ammonium nitrate we produced were, how many moles of ammonium nitrate? If you put it in your calculator, you should end up with 14,5125 moles of ammonium nitrate. So now we're going to use this mole ratio here, okay? So the mole ratio is 2 is to 7. So this is 14,51. Okay, I'm not going to write the 25 because it can't fit with my pen. And so what are we going to do? We need to do this calculation. So this is going to be 14,51, but you're using the number in your calculator, yes? Times 7 divided by 2. So altogether we should get 50,79 moles of gas. Remember to keep the number in your calculator. I'm just writing it here as rounded off. And then to work out exactly how much gas we've got, we're going to say N equals V over Vm. Okay, so we can say here, we can entitle this for all gases. Okay, so N was 50,79 equals V over 22,4. So my total volume at the end of the day, if you put that into your calculator, your answer is going to differ slightly from the textbook answer, but this is basically what the answer is going to be. And remember, your answer is going to come out in cubic decimeters because this formula uses cubic decimeters. So I've got 1137,78 cubic decimeters of gas. And then the last part says what special precautions should be taken when storing this fertilizer. If you look here, there's only ammonium nitrate. So it is decomposing basically on its own when you heat it. So you should store it in a cool place. And most fertilizers you should keep dry, but I don't know what that would do to the reaction. I don't think water speeds it up, but basically you must be sure to keep this fertilizer cool because otherwise you're going to run into a problem. But in this question it's interesting because you can use this mole ratio here of 2 and just add all of these moles up without calculating them, because that's the wonder of a balanced equation. Whatever's on the left ends up on the right. So if there's 2 moles on the left, this is giving me 7 moles of gas altogether on the right.